Hi, I am Akash again. This is the video solution for question 1 of Math Center, which is. So the question is, in a room containing 20,000 cubic feet of air, 600 cubic feet of fresh air flows in per minute, and the mixture is exhausted at a rate of 600 cubic feet per minute. What is the amount of fresh air YT at any time if the initial condition given is y naught equals to 0, and after what time will 90% of the air will be fresh? So with the given data, we have 20,000 cubic feet of air inside a container in which fresh air is flowing in at the rate of CFM, fresh air, and with the same rate getting out, exhausted, CFM, cubic feet per minute, exhausted. Now we can see that the rate of air going in and rate of air going out per minute is same. Input rate it equals to output rate. This implies volume of air inside the container will be 0. This implies delta V will be 0. There will be no change in the volume of air inside the container as both the rates are same. It will be 20,000 cubic feet at any time. We are given y dash t function for the concentration of fresh air inside the container, while y dash t will be the change in the concentration of fresh air, the rate of change of concentration in the fresh air, which is by the basic knowledge, input rate of fresh air minus output rate of fresh air. While we know input rate is 600 cubic feet per minute, we don't know the output rate. For that, we need to use the unitary method. Unitary method says if 20,000 cubic feet of air we have and it's flowing out at the rate of 600 cubic feet per minute. So what is the rate for 1 cubic feet? It will be 600 by 20,000 cubic feet per minute. And what will be the rate for YT? YT is the concentration of fresh air. So what will be the rate for the fresh air going out? It will be 600 upon 20,000 into YT. This will be the rate of fresh air going out. Y dash T equals to 600 minus output rate as previously 600 upon 20,000 y t y dash t. For better understanding, I will write this as y dash 600 minus 0.03 y. It will be d by 600.03 y equals to dt. Integrating both sides from 0 to y, 0 to t, it will be ln 600 minus 0.03 y minus 1.03 plus ln c equals to t, taking 1.03 common, and as it is a constant, it doesn't matter if it is there or not. We will take common out of that also. 600 minus 0.03 y equals to t. So ln c 600 minus 0.03 y equals to minus of 0.03 t, taking ln this side 600 minus 0.03 by equals to e to the power minus 0.03 t on 1 by c e to the 600 minus 1 by c e to the power 0.03 t, taking 0.03 y will be 600 by 0.03 minus 1 by e to the, we are given y0 equals to 0, so 0 equals to 600 by 0.03 minus 1 by 0.03 c e to the power 0.03 t, t equals to 0, so it will be 1. So c comes out to be 1 by 600, and while the equation we have was this, by putting the value into the equation we get 600 upon 0.03 minus 1 upon 0.03 c e to the power 0.03 t, putting the value of 600 1 by 600. 1 by 600, 600 goes. This is the amount of fresh air present at any time t, while we are need to calculate the time at which 90% of fresh air is present in the container. So for that we need to first calculate the 90% of what is the 90% of the fresh air. So 90% of 20,000 comes out to be 18,000 cubic feet. So we'll calculate, just simply calculate at what time the concentration of fresh air will be 20,000. 0.03 t, 3 zeros, 9, 10, so 0.9 equals to 1 minus e to the power 03 t, e to the power minus 0.03 t equals to 0.1, e to the power 0.03 t equals to 0.1, e to the power 0.03 t equals to 10. Taking ln both side gives 0.03 t equals to ln 10 is equals to 2.302, while t equals to 2.302 by 0.03, which is 76.7. So time required to reach 90% concentration to get fresh is 76.7 minutes. While the concentration equation, I will write it again. 1 minus e to the power 0.03 t. Thank you. This is the solution of question 1.